Okay, the next topic that we need to talk about is lists and arrays as function inputs. And this addresses an aspect of Python where Python actually treats arrays firstly differently from normal numbers and also differently from other computer languages. So somebody that's used to programming in C++ or Fortran, when they use Python, they must here be very, very careful. Okay, so they ask us the question, what will be printed to the screen? And they give us this example where we define an array foo with a value 592, and then we define another array bar equal to foo, and after we've defined bar equal to foo, we use indexing, like we've done just now, to change the the second value of foo, because it's index 1, to 100. In other words, we're going to change the 9 to 100 in record 6 of foo. And so it asks us what will be printed to the screen. Record 8 will print foo, so there we expect 5, 100, 2. I hope it's what it's going to do. But in record 9, when we print bar, what will it print now? In other computer languages, it will print 592. But in Python, it doesn't. And the reason why it does not, okay, that will become clear in a moment. So let's execute this. I'm importing NumPy. I define foo, 592. I define bar. Now note here that bar and foo points to the same array. Now, when we previously defined one variable equals another variable as a single value, it also pointed to the same value. But in the memory model, they are actually treated as two different variables because they have two different names. But this is not true of arrays and lists. Python do not consider them as separate arrays or lists. Python in the memory model assigns the same array to both names. So if I now in record 6 change the second element of foo, it's also going to change the second element of bar. That is what's different between Python and other computer languages. So note here, now foo and bar are both pointing to the same array, and the second element is now 100 due to record 6 having been executed. So if I now print foo, clearly foo is 502, but if I print bar, bar is also 5102. Okay, so please take note of this, which for you perhaps is not a difference because you may not have worked with different computer programs, but if you did, take note of this difference which may cause you problems if you later on forget about this. Any questions on this? Okay, so let's look at another example. Before we get to another example, important point here, this is true not only of arrays, but also of lists. So it's both true for both lists and arrays. And I haven't checked, but I think it's also true of tuples. So what will get printed to the screen? Let's look at this example. Now this is slightly different from the previous one in that we define a function and then we pass an array to the function, but then we change the array, we reassign we copy the array from vec1 to vec2 inside the function, and then we do the same inside the function. So the question is really what happens inside a function. So okay, so we define the function foo, which accepts a single parameter vec1, and inside the function it defines another parameter vec2 equal to variable vec2 equal to vec1, but then in record 6 it assigns the value 10 to the first value of vec2. So this implies really that vec2 and vec1 must be arrays. If you do this with an index on a single number, I think Python will generate the error for that. And then it's going to return vec2 to the calling program. Right. So in the calling program, it's what we have down here, including, of course, the definition or the import of the NumPy module. It will define an array called 1 as 1121, an array with 4 elements. Then it defines an array 2 by calling the foo function with 1 as the input parameter. So in other words, in the foo function, this vec1 will be the 1 that's defined in record 9. And then in record 2, it in a certain sense copies vec1 to vec2 in the function, and then it assigns a value of a value of 10 to the first element of vec2. And then it returns vec2 to the calling function, and that is assigned to the name 2. And then it's going to print 1 and 2. And so the question is, what is it going to print? So let's run this code to see what happens. So I define the function, then I define, I haven't executed record 9 yet, so if I execute 9 in the global namespace, I've got the array 1121, and then if I execute record 10, it'll call the function. So note now that 1 and vec1 inside the function points to the same array. Then I execute record 5 in the function. That defines vec2. And vec2 and vec1 points to the same array. So if I now execute record 6 in the function, where I assign the value of 10 to the first element of vec2, that it has done. But note that vec1 is also now changed. And if I now return vec2 to the calling program, let's see what happens. So the function namespace has disappeared, but the value 2, which is the output from the function, and the value 1, which was the input to the function, is the same array. Right? So if I print next, I print 1, I get 10, 1, 2, 1. And of course, if I print 2, I also get 10, 1, 2, 1. So once again, so what we see here is, even if I do this assignment of vec2 is equal to vec1 inside a function, it actually does the same as what it does in the main program. Namely that it uses the same representation of the data in the memory model of Python. That doesn't apply to single numbers. You can go and try that. It only applies to arrays and lists, and perhaps tuples, as I've said. So this behavior is the same for both lists and arrays. Objects are not copied when sent as inputs to a function, and even outside a function. So what it boils down to is you're simply assigning a new name to an existing object. You do not create a new object when you do this. So modifying the list or the arrays elements inside a function modifies the list or arrays objects sent to the function also. So in your main program, the values of the object has changed. Now, this raises the question, let's say I want to make a copy of an array. How will I do that? We've seen now here that if vec1 and vec2 are both, let's go to the previous example, that's perhaps better. I've defined foo in record 4. Let's say I now want to make a copy of foo, because I want to keep foo, but I want to do some operations on a copy. I cannot copy an array by using record 5. It doesn't work because it doesn't make a copy. The two names refer to the same array. So I cannot use record 5 to make a copy. So how do I make a copy? That's what this tries to address. And so there's a NumPy function called copy. So I can use the NumPy copy function to copy ARR. ARR now stands for some other predefined array. And it'll make a copy of array ARR into the variable A. So using this NumPy copy creates a new array in A. So you must remember this whenever you want to make a copy of an array. Now this is a NumPy command, so it doesn't work on lists. Remember, lists are not a NumPy object, it's a Python object. So to do the same with a list, you can simply use the command list. The command list is a function also. It takes its argument and it creates a list from the argument. So if I have an existing list called myList, if I then pass that as an argument to the function list, it'll create a new list called A. And I think at this point I should call it a day because the time is up. I'll carry on Thursday from this point.